And why should we go for a deep learning in the image processing, right? So can I have a simple question like, we are going to use a deep learning for some different applications, like it may be image processing, it may be something like audio, or it may be something like whatever, something 3D-dimensional, what it may be. But as you are aware of CNN architecture, the basic CNN architecture, is it a one-dimensional or two-dimensional? The inputs. One dimension. But whatever the image that we are giving is, whatever the video that we are giving is two-dimensional. And the first and foremost step in every image processing techniques is we need to convert our two-dimensional or three-dimensional image into a one-dimensional vector. So as the size keep on increasing, what happens? The number of computations keep on increasing, right? So let us assume a simple example like the image size is like 100 by 100. The number of input vectors or input neurons are around 10,000. Nowadays the input resolution is around 1920 by 1024, or something like 1000 by 1000, more than 1000 by 1000. The number of computations keep on increasing. Now, like, can you not tell me like how to handle this situation? Nowadays CPUs are not sufficient to handle these situations, right? CPUs are not sufficient to handle, but nowadays Google Colab is already, whatever the experiments that I have done is entirely dependent on GPUs only. Very basic experiments, like entirely done on GPUs only. Now, is there any relation between your CPUs and GPUs? Like in terms of order of complexity or order of speed, something like, almost it is speed, right? Compared to your CPU, GPU is almost higher speed. Roughly I am saying like how many times of your CPUs? According to the basic research, a GPU is almost 12.5 times speeder than your CPUs. 12.5 times speeder than your GPUs. But whatever the GPU that Google Colab or someone or else Kaggle or else GitHub, whatever that they are giving is around 12.5. Not more than that. If your memory is exceeding that, so we cannot handle the situations. So we need to have a predefined GPU on our system, then only we can handle very huge database. Whatever thing I have taken is only, I have applied only one algorithm. If I want to apply one more algorithm, then I cannot apply, and because already the memory is being exhausted. We need to refresh and we need to clear it out and we need to take it out. Or else I need to have a clear cut one more like a GPU. But still, one more question is like, still GPU satisfies my requirement, or else industry has been stopped at the point, or else what is the need for a VLSI design engineer come to this point? Like, not all relate to me, right? As a VLSI design engineer, why should I come here? Nowadays this GPU is not at all sufficient. GPU has been exhausted. Google Colab is giving it a free of cost because for you guys to try it out. So we are having some basic knowledge, right? We will have some basic knowledge, we will apply some things and we will come up. But still, GPUs are not at all sufficient. GPUs are exhausted once again. Nowadays people are looking for the hardware accelerators. Can anyone tell me like, have you heard about hardware accelerators? Right? So hardware accelerators are nothing but just like a chip in your systems, which will increase the performance of your system, just like CPU to GPU. I have already told about it is 12 times higher speed compared to your CPU. In the same way, hardware accelerators are 50 times speed compared to your GPUs, not CPUs. It's 50 times higher compared to the GPUs. So effectively, a single hardware accelerator will compensate for 600 CPUs. That's why most of the people are looking for the hardware accelerators to design each and everything. I will show you a simple demo at the end, like how my hardware accelerator has been improved and how the performance has been keep on increasing. And even though it doesn't care about the size of your inputs also, it directly fetches everything. The hardware fetches everything from your systems. It fetches everything, just like your what you can say, Have you ever tried about like a generated adversarial networks, GANs? We have heard about GANs, but it is highly impossible to realize the GANs. Nowadays it may be possible, but like 3 years back, it is a very highly impossible for to realize a real-time GAN. We can implement a simple GANs. I am not bothered about those things, but a complicated GANs, is it possible? But with the advancements of these hardware accelerators, it made our life easy to implement these GANs in real world. Like, I hope you might have seen the application of GAN. Recently, newspaper came. Like, what is the best example of GAN? Recently, I think students might have known like some deepfake photos they have released. Right? This is the best example of GANs. So nowadays, if you have learned about the GANs, we can do everything. We are learning the deep learning to implement everything. Like we can do image denoising, we can do like image segmentation, we can do image compression, we can do everything. But in the same way, now the next era will be like GANs will be everything. Like if you want to generate an image with the help of some noise, I can do with the help of GANs. Everything. Like deepfake nodes, best example. So with the help of GANs only they are generating. So in the same way, so hardware accelerators have been very much useful for improving the speed as well as performance of the system. Now here, in this example, I am being shown only GPUs. In the next example, I will show once again how to use the GANs, how to use the hardware accelerators to improve the performance of your thing without compromising in accuracy. So here what I have taken is like a simple example, like a skin disease, like a skin lesion disease detection, lesion affect like cancer. So I have taken 10 different types of sets, 10 different sets. Each set consists of only a limited number of images, roughly maximum of 50 images. If I want to go for a more and more number of images, then definitely the memory will be exhausted. The maximum images I have taken is 10 classes. Each class is having 50 different images, and I have been trained. The first phase of every CNN, there are 3 different phases. I hope everyone might have been known: training, validation, and testing. So for training and validation, I have given around 80%, and the remaining 20% I have allocated for only for testing purpose. So I have trained with different algorithms, out of which I am being only concentrated towards pre-trained neural networks. Rather than going on designing a network on my own with very little knowledge. Because if I want to design a CNN, I need to give like justification, like why are you choosing those many number of hidden neurons, and why are you choosing those type of activation functions, why are you choosing like a bias, what type of bias you are choosing. Like, I cannot answer all these questions within this very limited number of time. So I need to use some predefined neural networks, which are nothing but pre-trained neural networks. Already everyone might have known, like you can search from like a TensorFlow hub or somewhere else, you can get n number of models. You can plug and play. Only we need to choose about how many number of output layers we need to have. Only choose the output number of layers, and different application can be built within a matter of max of 5 to 10 minutes. Only we need to choose a proper network. The data set should be very clear. We need to have a very clear data set. If you don't have a proper data set, even though your algorithm is very good also, it will leads to your very bad results. So first, data cleaning is very important, and trustable sites only we need to download. So that is first important. After I have downloaded the things, I have gone for a different. So this is the thing I have done. I have researched some sample images. After that, what I have done here, you can see that I have used some VGG-rating network. So generally VGG model is used for image segmentation. So if you go for like some standard models, then they will display like each model is meant particularly for some certain applications. VGG90 is meant only for image segmentation. If I am going to use some other different models, then it may lead to a very bad results. Because these are pre-trained networks which are used only for segmentation purpose. So I am using for the VGG90 layer for the segmentation purpose. As already I have said that how many number of outputs you want. You can mention the number of outputs. So once you mention the number of outputs here, and so here there are 9 number of outputs. So I am going to classify into 9 different sets, and you know that output activation function should be softmax, none other than like you cannot use like ReLU or something else, because you know why we are choosing only softmax. We need to do the decision. Okay, for decision taking purpose we have taken the softmax, and the number of layers I have taken the number of outputs is 9. If my number of outputs is around like 3 or something else, you can mention there like 3 or something else, and you can train them all. Now the training is for the entire network, or it is only for the output layer? No, because we are going for a pre-trained model. Right? If it is our custom model means then we are training the entire network. But if we are going for a pre-trained models and the weights are also fixed, you can download the weights from the network like the web page like ImageNet or something else. So you can download the weights and you can simply place the weights there. Instead, if you want to train the entire network means once again we are going to exhaust with the memory as well as everything else. So we are loading with the memory sets, we are loading the weights such that we are saving most amount of time. That's why nowadays only like pre-trained networks are useful, because our entire weights are being loaded. Only we are training only the output layer. We are not loading with the entire input. If you want to train the input layers also you can train. Simply like you need to mention that we are include like some pre-trained network to true or false need to mention. If it is a true means we will train the entire input network. It will like it is not suitable, because we are choosing the pre-trained network only to save my time as well as resources. If I want to go for the entire network training, then I can choose my own custom CNN model. Why should I choose for pre-trained models? Pre-trained models should reduce my time as well as improve my performance. Now if I want to go for something like VGG, if I don't want VGG16, I want VGG19. Simply in the place of here VG19, I can press VG16. So within short span of time, I can do the results and I can compare with almost n number of models within a short span of time. So this is the thing, like different models, like different layers of the neural network, like what is my input layer, what is the purpose of convolution 2D, and I hope everything, the meaning you know, like how I am considering from 224 by 224 a last 3 by 3 or 1 by 1 or 9 by 9. But you can see like these are the pre-trained models, that's why the size of the input image is 224 by 224. If you are going for a custom CNN model, I can fix the size of my image, like it might be like by 500 by 500 or 1000 by 1000. But since it is a pre-trained model, each and every image should be resized to 224 by 224. Once again, the accuracy of my model once again depends on what is the algorithm that I am choosing for resizing my input image. If I am going to use like a normal nearest neighbor algorithm or something else, it will degrade my results. So I need to use the best algorithm and resizing the images. Once everything is done, here you can see the number of parameters keep on increasing. The rightmost side, the number of parameters keep on increasing. Here you can see that like there are around like 20 billion parameters are there. Out of which the trainable parameters almost are like 2 lakhs. 2 lakh parameters only I am going to train. Remaining non-trainable parameters once again 20. So from that also we can say that I am not going to train the entire network, I am going to train only the output network. So because of this only the outputs will come around in the matter of like half an hour, maximum of half an hour. Like if I am going to train the entire network, entire 20 million neurons, entire 20 million weights and biases, if I want to train this, imagine how much amount of time you are going to get and how much amount of resources it is going to consume. So it is like we need to buy a separate GPU. And here you can see like most of the faculties we look for only like different metrics to compare. So now for example, it might be MATLAB or something else, we want to do comparison is we need to write everything. Now here simply we can import whatever the metrics you want. Like I want a metric like accuracy, RMSE, like some other You can choose the number of metrics on the website. Everything will be. Like you can import all the metrics. You can import all the metrics here, and you can plot whatever the graphs you want. You can fill the entire graph. So, like as I said that there is one more important thing like image data generators. Can I know the purpose of image data generators? So, like whatever the data that I am going to supply that may not be sufficient, so I need to increase the size of the data set. So for that purpose I am using here very basic data generators. It is not an exact data generators. If I want to go for exact database generators, I need to mention what is the amount of rotations. I need to mention what is the size of scalings. I need to mention what is the amount of rotation, everything, sharing, everything I need to mention. If I am going to present all the parameters, once again I am saying I am going to generate the images. For example, with 10 degrees, all the images will be turned by 10 degrees. With the sharing of 10 degrees, all the images with the sharing of 10 degrees. It is going to generate different images with the different parameters, whatever things I have supplied, it is going to increase the database. So, increase the database so that the accuracy will be improved. Now compare with the normal image processing methods with the deep learning methods. For example, have you ever tried with the normal image compare with you take your photo and tilt your photo with 10 degrees or 2 degrees. Take your photo and tilt it with 2 degrees and try to give the two images to your MATLAB or Python. A normal comparison. It will do by pixel comparisons. If you are trying to do the pixel by pixel comparison, definitely it will give like okay, both are not same, it is giving some amount of error, so definitely both the images are different. But whenever we are training the images with a different shading, with a different like angles, with different scalings, all the possible images will be generated in the repository, and we are going to compare the Anil with the different angles and rotations, everything. That's why already I said that we need to have a GANs. So if I am going to take my photo and I am going to give it to the GAN, it will generate, okay, Anil is like this. If Anil is going to be like in a sad mood, how is going to be? If Anil is going to be like laughing mood, how is going to be? If Anil is in a different mood, how is it? So it is going to generate different images and will make the database. And I hope you might have seen the applications of some apps are there like if you are going to give your photo at this age, it will try to project what is your age after like 5 years, 6 years, 7 years. It is also a best applications of GANs. So it will try to generate the images and we are trying to compare with the images. That's why your deep learning comes into the picture. So already I said like training and testing. I am going to divide my entire images into training pass and testing pass. I am dividing the entire images. So 80% of the images are meant for training and 20% of the images are meant for testing, and I am comparing those things. So there is one more important feature which most of the people in deep learning might use is callbacks. What is the purpose of these callbacks? Like for example, you are training your neural networks and after 4 years, because I want to train like almost like 10 epochs or 20 epochs, because as the number of epochs keep on increasing, the accuracy keep on increasing. But unfortunately, in the third iteration or fourth iteration, you might have achieved very good accuracy. Is it suggestible to keep on the next 96 iterations? Because already I have achieved 95% accuracy in the fourth iteration itself, 95% accuracy. But is it suggestible to keep for running my algorithm for the next 95 iterations? Not suggestible, right? I can call back my things using the early stopping algorithms. If you are not going to mention this one, the algorithm will keep on running for the next 95 epochs, and it is going to consume your memory, but at the expense of reducing accuracy. I hope you understand the point. At the 5th iteration itself, I have achieved a point of 95% accuracy. At the 100th iteration, the accuracy I cannot give guarantee it is more than 95%. It may come down to 95%. That's where your overfitting comes into play. In neural networks, there are 3 things like it is a perfectly trained, overtrained and undertrained. That depends on the database that you are going to provide. So if you are going to train after it is being perfectly designed also, if you are going to train means the performance of the model will keep on decreasing. So that's where we need to use the callbacks compulsory. Without the callbacks, once again the memory keeps on increasing. So for each and every iteration, we can compare the accuracy, how it is keep on increasing, 29, 49, 55. So after some iteration, like it is almost 73, 74, 76. Now if I keep on some may suggest okay, with the 10 epochs or else 11 epochs only you have achieved a very good accuracy of, very good or bad I don't mind, you have got an accuracy of 76%. Why can't you increase the number of epochs to 20 and get a value of 90%? Okay, why can't you increase the epochs to 50 and get the results? But why we cannot do? Already I mentioned that if you are keep on increasing the number of epochs, and it will consume a lot of money. That too I am going for a pre-trained modes, not a custom trained modes. So here I mentioned, so you can see 50 is the epochs value. So 50 times it needs to run. But I am going for a callbacks. If my desired accuracy I am satisfied, simply quit from that step, sufficient. So here you can see only 5 out of the things. Sorry, I think there are something that here is not displayed. It's more than that. I have compared two different modes. If someone wants to go for a different model, you can call, for example, instead of BGG, go for some other different model. Place it Alexa or something else. Place it there and do the things. So no need of spending extra time to generate all these things. So I have compared only two different models. So this is one more model BGG 16. So one more model is Inception V3. So I have mentioned here where I have got this thing also. From TensorFlow Hub only I am getting everything. So Inception V3. So I have compared everything. So what is the amount of accuracy? Similarly I am going for ResNet 50, ResNet 80. So whatever the models you want, you can do. This entire thing is only meant for a pre-trained model, not for a custom model. So in the same way I have gone for a diabetic retinopathy for a custom trained model. So here you can see that I am going to design everything by myself. Like what is the input size? What should be the next size? What should be the next size? So what type of activation function I should use? What type of cooling functions I need to use? Everything I can design. But I need to have a clear-cut idea like what should be my output, what is the input resolution. Here there is no restriction like the input image should be of 224 by 224. The input image size be of anything else. But all the entire database should maintain the same thing. Then only I can give a guarantee. For example, if I am giving design the entire network with 1000 by 1000 and someone has given the image of 1000 by 1100 1920, then it may not work. I need to once again rescale the entire image and I need to give the input as required. Otherwise, once again it leads to performance degradation. So here you can see that what are the for every step in the CNN. One is convolution tuning, max pooling and batch normalization as well as activation function. What type of things I need to use. So like that I use n number of models and the n number of layers. These layers also I need to do justification. How many number of hidden layers should be there. I cannot simply keep on increasing number of layers increase 3 I am getting accuracy of so and so. Something like 70%. I can increase the number of layers to 5 so that the accuracy will increase to 75. Increase the number of layers to 10. I can improve the accuracy to 80%. Improve the number of layers to 20. So I cannot keep on adding can do something like that. There should be some rule. The rule will be the number of inputs and number of outputs. Simply add the number of inputs and number of outputs. Almost 2/3 of the thing should be your input hidden layers. 2/3 of the number of inputs plus number of outputs should be the number of hidden layers. That should be the rule of thumb. There is no hard and fast it's based on the number of experiments some past researchers have done and they have come to the conclusion and is already displayed in the white papers also. You can refer to the white papers. 2/3 of the number of inputs plus the number of outputs should be the number of hidden layers. that optimally an algorithm should choose to give the better accuracy. That's what we are using. Like I have gone for those models and I have presented everything. So there is one more, like it's the same model. What is it displaying like at the end? So I am comparing the different models. So like this I have done, but what is my intention is like, what is my intention is like, how should I use the hardware accelerators to improve the performance of my models. So without already I said that we know about CPUs, we know about GPUs, but what is the advantage of hardware accelerators such that it will improve my performance, or else it will improve without the compromise. Now what are the limitations? Accuracy is my one of limitation, and second one is what is the amount of space and amount of performance. These are all the things comes to the picture. Now the same application like segmentation or else picture identification. Here I have taken a simple thing like identification from the web. So how much amount of time it is going to take and with the accuracy. But one thing is like I have taken very huge database here, and the database spans around like 6.4 GB is the amount of database that I have taken for training purpose only. After that, I have taken a sample image from the web, and I have given as an input to my algorithms, and I have checked what is the amount of accuracy. So these are the different application areas where we can use, and right now industry is working in. So there is one more area that I am working on, like as a part-time only I am working on this field. Like right now, till now we have seen only image denoising for a single type of noise. Either it may be like impulse noise, it may be like a Gaussian noise. For Gaussian noise, we are using some Gaussian filters. Some impulse noise, we are going for either a median filter or IQR filters. For speckle noise, there is some different filter is there because there is multiplicative in nature. The top two are additive in nature. So for different noise, we are using different filters. But right now I am trying to almost at the 50% level, like a single deep learning model which will identify the type of noise present in the image and it will try to remove the noises. A single filter. I don't want to go for I don't know because whenever my image is transmitted over the channel, I don't know which type of noise is going to be affected. Maybe channel because of its additive nature, maybe some solid vapor noise or Gaussian noise, or due to the manufacturing defects of my camera or else at the display, maybe some speckle type of noise is happening, or what are maybe the reasons. I don't know what type of noise is there in the picture. If I don't know what type of noise is present in the image, how can I say that my algorithm is going to be the best? So for that what I am trying to do is I have taken different algorithms and each one I am trying like from 5% of the noise to 80% of the noise. All the different varieties of the models and all the different types of images and training. So once if I custom CNN model, if it comes to the picture like it needs to identify the type of noise and roughly the amount of variance present in the image, noise variance present in the image, then I can easily remove the things and I can easily present the things. So that is one more area right now I am looking at. So it is a multi-layer network. I hope you are aware of these things. I don't want to stress on these things. Multi-layer networks. And here once again I have gone for a standard image size because for me to prove myself, like I have taken a standard 224 by 224 image size. So the main function is like here my requirement is storage space and processing. So those are the two requirements I have taken. And this architecture of CNN, there is a basic architecture. I am not done for an in-depth or something else. Here my main concentration, as I already said, that it should come within a short span of time, as well as there should not be any limitation on the memory size or processing time. There should not be anything. So I have designed and realized everything in the hardware. These are my own things. With the help of some Xilinx device I have taken and I have done everything.
So you can look back the white papers in the hardware, like in the Xilinx white papers, you can be aware. You can check